So in calculus or pre-calculus, it's important to understand the concept of a one-to-one function. That's just a type of function that's often come up in later mathematics that you should be familiar with on how to check. It also comes very intuitively, so I'm sure this will sound very familiar to you or just make sense. A function is one-to-one whenever if you can choose an x value like x1 or x2 within the domain and get a unique y value to like y1 and y2. So if there is one y value to each x value, then you have a one-to-one function. And a simple test that we could use when finding this out is called the horizontal line test. And that's what the theorem says underneath, is saying that like if you cannot draw a horizontal line passing through the graph multiple times, then you don't have a one-to-one function, or you do have a one-to-one function. It's only one-to-one if you can only draw one horizontal line passing through it. That's what I was getting at. Understanding one-to-one functions helps us set up the definition or characterization of an inverse function. An inverse function can only exist when you are operating within a one-to-one function. Again, this kind of comes intuitively, and you might have already like figured this out, that an inverse function is when you are evaluating the function with the x value, you get a particular y value, and the inverse is when you evaluate it at the y value and get a particular x value. Inverse functions can go back and forth. You can take the inverse over and over again and get the original after so many times. So if you have two functions that are inverse functions of each other, then the domain of your one function is the same as the range of your other function, because like I said, like taking the inverse is like similar with like evaluating the function with respect to x or with respect to y, and just consistently getting the same values back or inverse values back. So continuing forward, some properties about inverse functions is that when you have a function of g that's an inverse of f, then you should be able to have an inverse of, or a function of f that's an inverse of g. And if they equal each other, then you have like a one-to-one function, and this all operates smoothly. That's when you can say the domain of f and the range of the inverse of f, and the domain of the inverse of f is the range of f. We can use the inverse also to like help define like real functions, like a point AB only exists on the graph if the point BA exists on the inverse graph. And if the inverse graph remains to be a reflection of the original graph, then you have an inverse function. So all of these properties of inverse functions helps when trying to find certain elements to your function or your graph. So it's just good to be familiar with these.